yeah, so let's just kind of, I'm gonna try and just do like live coding and show you guys this project. I I basically just like stripped a lot of what was in the book with of all of its content. So we're just gonna be like kind of copying and pasting a lot of what the book shows up, but in a more streamlined fashion.
Works for me.
Um, so let me screen. Let me change things here a little bit. Let me set up for that. Okay, so here. Um, cool. All right, you all see that?
Yep. Yep.
Great. Cool. So it's a project. We're building a command line program. Uh, so these are kind of the requirements of this program, right? It has to have some argument parsing. It needs to be able to read files and search for strings in those files, and then some sort of error handling and environmental variable configurations, and then how to print standard errors instead of as a error instead of printing errors in the standard output. So these are just kind of what we need to be able to do or aim to do. So we're just gonna I'm gonna move this to the side and just start doing these things down here. Basically, we're gonna say cargo new mini mini grep, or you can call it whatever you want. Cargo handles aggregation of the new directory with its cargo, the tunnel file. So we move into mini grep. I know this is kind of small, but I have all these things that kind of just show up. But so yeah, we've just created. We are in our directory. If we see it on the side, we should have a source, a get ignore, and a cargo tunnel. So that's just starting to set us up. And now, basically, in our main RS file, which I'm just gonna kind of go here and open, we're gonna remove what cargo gives us, the hello world spiel, and we're gonna copy and paste this. So saving it. So here, this is just a main function. We're calling a standard library and what is it? Methods or a method environment? Yeah, or a module. And then we are just collecting some arguments, right? Have it and detect and handle arguments that we put into our document, program. So now we run cargo run, and then it builds, and now our tool is called target debug mini grep. So if we go and use it by saying cargo run dash needle haystack, basically it's just taking these two arguments and returning them back, right? As like, hey, you gave me needle, you gave me haystack. It's not searching through the file, or like the contents of a file, because we haven't gotten there yet. So we have it working. Our API currently can take arguments. Now we have to save those arguments in variables in some sort of way to then be able to use it for searching. So if we go back to our main RS file, we're gonna copy and just kind of add a couple of lines here, but we keep our variable of arguments to be a vector of strings. Now we have another variable called query and another variable called file path, and those are references to the args variable that we've created up here, right? So and then we're printing for them, right? We're saying, I'm searching for whatever you've put in the first field, and then in whatever you've put in the second field. So when we save and we say cargo run test sample txt, it says, hey, it's searching for test in file sample.txt. Actually, when I wrote this, I put some backticks just because I like understanding what word I'm actually searching for. So if you run it again, it just says searching for, test, but now it has some backticks, and that was just a pet peeve of mine to help me say, hey, this is the term or argument that you are searching for. Just because there's no color coding here. So we've saved our arguments and variables, we've run it. So now we can, and it also gives us some sort of information of what it's doing by printing, using println macro to give us an idea of what it's doing. So to read the files, we're going to call another, actually, I'm going to rely on you both. Is it in the standard library? What is this? Is it a module or is it a, I'm a little bit confused.
Oh, yeah, I think it would, would it be a crate?
Or a crate?
I don't know.
Yeah, I think it's a module or a crate. Sorry.
One of those two.
Hey, I didn't know there's gonna be a quizzes thing.
Yeah. Sorry for
That is funny.
in this one I still get it. I've just gotten like macro function statement and expression, but this part. Anyways, we're basically just calling another one from our standard library, and if you've kind of been reading, we can kind of do shorthand on this and say, env and fs, if I'm not mistaken. So from the standard library, env and fs, but let's just leave it.
I think you're right, those are modules.
Modules, right?
And the modules are in the crate, right? They're in the standard crate, I guess. Is that right? I don't know.
And it's yeah. So now we're adding, so we're basically eliminating our query and our query variable and saying, okay, we continue to have our args or arguments variable. Now let file be a reference to the second element of args. And now we're gonna say, now we have a variable called contents, and then using that fs, we're gonna read string. I think this read string is a function from that fs module, and then it's going to print some information, right, using the expect function and println macro. So we save it. I'm using positron here, so if you saw that change, I have it to like auto format, so that's why it changed a little bit. And now we say cargo run the poem.txt. So now I'm saying, well, I don't have a poem.txt file actually. I think this is my bad. But I can go and make a copy of, and that I have it in another folder. So let's just go here and paste this file here. All right, so you should just have, make a simple text file that has poem.txt, and then copy and paste the information that we've been given kind of in this block here that says cargo run. So again, if I run it, now it basically prints out. It says, okay, I built the API, I ran it, and now it basically prints out everything. So it's running. I don't have any errors or anything. Now we're gonna. I think this was for me the interesting part about building this project is when to move things from your main function to your libs.rs file, and just kind of how to handle those. So we're gonna make an argument parser. So our main function now is basically gonna be using another function that we use. So I'm gonna move it here. So we're moving the parsing logic to its own function called parse config. And again, it's saying we're again bringing that variable query and file path, and these are references to args, and args is a variable in the main function. So once we do that, this is kind of how our program should look like. And now, so what's been going on is that we have a tuple which we then break down into parts, right? So with main, we have this vector and that with arguments collected. Then we have this two variables that are being referenced by the function parse config. Essentially, we end up with a tuple that we then break down to see if our word or term is there. But now we're going to be using structs, and then configuring the parse underscore config function to handle that struct. So again, so now our main function has arguments config referencing function parse config, a couple of print or messages here. We've created a struct config has query, and then query is of type string, file path is of type string, and then we've updated it to parse and handle the contents of a struct, right? So we've Now it handles strings or references to string, and the resulting of that, this signature is it's a struct from config, and then we've said what those contents of that struct are going to be, right? So we've created the struct. It's going to be a general string, and then what they are, they're a clone of argument, the args variable, which is from main. Excellent. So yeah, we don't run it here again, just kind of looking at, how we've kind of broken down, use structs, and then filled in the information, the fields of set struct with the parse config function. So I guess that's what I was summarizing. Yeah, this is a checkpoint. Yeah, we've updated main, have struct config, the function parse config, what we've done, separated, and this way we've just kind of ensured that the code can find the values in the config, the variable config, not the struct. So now we have the config variable here. All right. So everybody, I don't know if are you all kind of doing it or just?
Yeah, I'm following along.
Sure. Nice. So, all right, let me go here. So now we're gonna create a construct. Oh, and so in this presentation, you can all click on the headings, and you can go basically to the book. So I put hyperlinks on that. So if there's kind of questions or about that or clarifications needed. So we're going to create a constructor. In here, we're basically turning the parse config function into an implementation, and we're just going to change its name. And in doing so, we have to update everything else. So just kind of copy and paste the big one. I think when I did this back, I was like adding this little part, the implementation config part, and then I forgot that you basically need to update, according to the variable name and things like that. So here, save. Yeah, so what we've done is just turn that function into implementation of the config struct, which then has a function called new, and this is pretty much the same as the parse config function that we had before. Now we're going to add some error handling to this. So everything else, look at it, I think pretty much stays the same, and these highlighted lines is what kind of changes. So we're just adding an if statement before function, or sorry, within the function new. So we're saying if the length of the argument is less than 3, hey, not enough arguments. And I think this is, not inclusive of 3. So yeah, basically there's not enough. You need 2 arguments to be able to use this. So when row the cones, so for example, if you just run the last cargo run, it should run this. It should still kind of run the same, but if we say, hey, we remove, now it says, I just gave it 1 argument. It says, hey, it panicked. You don't have enough arguments. You did something wrong. So it really wants you to and now the program really wants you to put in 2 arguments. Now, instead of panicking, what we kind of want is to return our result and check for errors differently. So we're going to update our config implementation, and instead of saying, hey, if it's less than 3, panic, we're going to say, hey, return a result error, not enough arguments, and then we're also going to add okay. So instead of panicking and dropping, we're like stopping. Now our error can handle that, can give us a kind of a second chance to. So now it has a bit more instructive and more informative result. Hey, you're trying to build, and consider build, for example. This is
You got to fix the main too.
Oh yeah. Sorry, and I got ahead of myself. I need to update main, because I updated the implementation, but I didn't update main, and then this is why it's saying, hey, you have config here, the variable config calling struct config, and now it needs to say build here, if I'm not mistaken. Yeah, so now it just gives us.
Now you got to unwrap that because now it's becoming a result back.
Let me just copy it. Let me follow my instructions and just copy what I pasted here, because it just slightly.
Well, you pasted too much, yeah.
Yeah, I mean, just slightly different. Cool. All right, I think that will do it. Okay. All right, I'm gonna get there. There's mismatch types. Cool. I did this correctly. Yeah, it's fine. Okay. Continue. So now we're just gonna make in this main RS file, we're gonna separate the logics a little bit, and then our main function is going to be just kind of handling or referencing another function that we're going to make, which is run config. So we're going to add that one here. Save, and I think I need to add this part print. Run function takes config instead. Yeah, so now run is the one that's going to be using struct config. Set that up. I have a feeling I might have copied this wrong, so let me check for a second. I have a feeling I did this wrong. Struct logic. Create a constructor. I have another document here. This is the finished result. So yeah. So it's gonna have this, and then we're basically, as we work through it, we're gonna be eliminating these things. But
I guess you don't need the lines after the run config anymore, right? Because those, or at least that one line, or maybe both of them, because they're in the
let contents.
Yeah, because that's in the run function now.
Yeah. That's you're completely right. Yeah. So
There's
much
something wrong with-
copying and pasting. Huh?
There's something wrong with config though, I guess. They are build because it keeps complaining. But does it work now?
let me check it out.
Yeah, it says it can compile expected config. What is the build function look like? Maybe you left something out of that. Did you
Which
remember to
function?
okay the build function? The
You're totally.
okay.
No, it does
config.
have the okay.
I don't know. Why is it not working now? Seems
I
like it
think
should
I
work.
think I think I went through this last night. So let's hold on.
Oh no, no, that's fine.
It's just very different then because we're gonna split it into like
Yeah.
live RS.
Yeah, I only have my
So-
final version too, because so I wasn't
Yeah.
really following along with you here. I did it last night. I didn't know you were going to do
Yeah.
that. I waited. But yeah.
Okay. Main friend. Yeah, I'm gonna trust that we're doing that right. All right, let's continue. All right, so we're gonna improve that error handling by calling it yet another module from the standard library, which is std error. And we're gonna add that over here, and then basically we're gonna update our run function to just handle things a little bit different. Oh, yeah. Let's handle things a little bit different. So now, so this is how it was, right? It takes variable config, which is struct config. That's a function signature. Now the function signature changes to a result type bot stem in then dynamic error. So now we've replaced the expect with the kind of the question mark operator, and which helps us propagate errors to the color without panicking. And now it explicitly runs okay. Right before it was saying we had an okay here, but now we're gonna just have another okay over here. So now if we run it, yeah, on the process. Actually, we're gonna be using this one soon. So the compiler is telling us, hey, consider importing this module. Well, we're gonna get to that now. So, no. Oh, look, this is fun. This is why I did this, so we can reference the whole thing of how it should look like. So, this is where we should be at, more or less. Oh, here's the error where I have an imported process. And it basically tells us to import process before. That is a mistake on me copying and pasting when they're like this small, I don't really see what's being called.
Right.
So, all right. So here, let's see if it looks the same. Yeah, we're pretty much calling the same ones. Config, promise parts in S1. We have run config. This has changed because it changes in the next step, which is this one. So this should be looking good. Okay, now we go back to our presentation. That was why I did that. So let's see if we actually can run it and it tells us something different. There we go. Now it's working.
And then if you don't have if you only have one argument, it probably just has a single line error now, right?
Yeah. So if I just put one argument, it says, hey,
Yeah.
problem parsing, etc.
Awesome.
Okay, problem solved. All right. I will update that in the presentation to kind of, so I think it was in this one that I didn't copy it with the modules. So my bad. Now, all right. That's how we're gonna handle errors. Return from run in main. So in main, in the main function, we are gonna add this information, an if let statement. Which basically is telling us the errors, check for errors in the run function. So we should be able to run this again. Cannot compile main due to previous one error. Yeah, so it's giving us that. Let me see. Did I copy that correctly? Okay, so I need to eliminate run config here. Excellent. Okay, now it's working. So, okay, so now basically this has gotten big, right? We have a main function, then we have a run function, then we have struct, and then an implementation of that. And what we want to do is kind of separate those and make a library crate. And so our kind of directory structure should look like this. We have source and we have our main RS and our lib RS. Basically, you know, what I did here was just I make a new empty file, and we're slowly going to be moving things into that file. But the idea is to keep certain logics, the config logic, the run function logic in its own library crate, and then the main function alone also. So this is how it should look. So our librs, we're going to move this information. So let me take a couple things out. I'm going to take these two out. I'm going to drop them here. I know I can just copy and paste, but I want to clean it up here. And now I'm going to move this to my librs. Struct implementation. And then now I need my function. Yeah, I put it at the end. I apologize if you hear a cat in the background, but it says
That was my cat. He's around here somewhere too, man.
feeding time, and he's a pain in the butt. Okay, so now, okay, we've cleaned up our main, so it should look shorter. It should just be one function, and now we have lib. But we need to make a bunch of things public. We need to make liberal use of public. So we make public our struct, the function build in the implementation, the fields in the struct, and things like that. So our two files, just this is how they should more or less be looking. So, well, I still have this print. We're going to eliminate those prints. And now we have, since we've created, taken that logic of the struct, the function, etc., into its own library crate, we can call it from our main function. So we're going to bring it in scope and say, hey, config. And so this is how our main function should look like. And now we're going to develop some tests for it. So in right. Okay, in our librs, yeah, that's where we're gonna work. Okay, in our librs, we're gonna add this information. So at the end, we're gonna add this information for writing a failing test. And then we're also gonna create a search function for it. Now we save it. And I think I say cargo test. And the result should look something like this. Maybe I did something wrong. Out find function run in this scope. I did something wrong. Standard process media. Oh, yeah. I didn't in main. I need to update here. Main, my iflet, I need to say mini rep run. So now when I test, let's go here. It's it run, right? It runs the test. We've built a failing test. And this is how it should look like. So be sure to update your if late statement in the main RS file. There we go. So now we're going to write code that passes. And then, so we're basically in our librs file, basically updating our search function. And this is what it's going to have now. I added, this is, I added these like steps or broke it down into these steps. Where step 1, we iterate using the lines method. Step 2, we search each line. And then step 3, this one, what we got in this one, we're trying to store those matching lines in our vector of results. So when we do that, we save it. And we update our search function in the run function. So we have to go to our run function up here and update it. Let me see if everything's all right. Yeah. Let me just copy it all. I don't want to make mistakes again. Oh, drop it in here, and we can say cargo test. So now our test pass, right? cargo test, result, etc. We can use it, we can test it by running something different, cargo run. So it in poem, so it works, right? It looked for the word frog in our poem test, and it gave us the line that has that text, that string. Now we're going to change the working environment variables to write a failing test that is case insensitive. So now we just change this test section. We're gonna basically change it to incorporate all of this. So we're gonna have a case sensitive function where it's gonna have some strings there that are case sensitive, and then we're gonna have a case insensitive function and test again. So now we need to make an implementation for that case insensitive search. So we have our our case sensitive search here and our case insensitive search down here. And then we can test. So it passes both tests, right? Runs two tests, case insensitive, the function and the implementation work, and then case sensitive as well. Now we need to just update. Why did I put this here? Update config constructor function. Yeah, let's update that. So so we're creating an ignore case. I'm sorry. Yeah, we're creating an ignore case, and it's a Boolean. So our struct now has a new field called ignore case, which takes Boolean. And our run function now is going to handle that. So now our run function has the search case insensitive function, and then so let that. If else, you're going to use the search variable query contents, etc. Yep. And now in that same file, we need to update the implementation of config to handle environment variables. So here we just have the query and file path variables, and we clone them from arguments. Now we're adding an ignore case, which relates to environment variables that we're gonna test in 1 second. And our OK changes, right? So our OK is struct and any of these fields from that struct. Test. Error on the grill module and why did I do that? What happened? Oh, I didn't update that. So now lib needs to have views, cd, and now if we run it, it should work. Yeah, now it works. because I was missing that module. So excellent. So basically our library create is going to be the longer file, and then our main should just have the parsing logic, right? So we can say, oh, this is how we're gonna, where our errors are gonna be written right now. And what we see is that it writes all the output to standard output. So we go here, it would kind of comes out like this, but we want it to, or here, for example, cargo run. So now I look here and I should have this little file here, right? So it created a file saying what the problem was. Hey, and it gave me the error message as a file, but we're gonna have it so it just prints it out in the console a little bit nicer. So yeah, we wanted to be able to save it to a file and make it visible to the screen. So in our main RS, we're just going to change how the macro that we're using. So a simple change.
With the letter E. So yeah.
The letter E. Yeah, I'm making sure that it's the letter E because that. Yeah, it's basically the letter E. Pub. It's just another macro that you can. They explain the differences, but I can't really recall right now.
It's just a matter of going to standard error versus standard out, right?
Standard out, right? Yeah. So yeah, now if we run it, or cargo test or cargo run, it's gonna give us the output here on the screen and create that file, as opposed to before.
Right, and the file would have any proper output if you had any, but in this case you won't because it aborted. But I guess if you're like printing warnings or something, that you could still keep pressing on with the analysis and for whatever you're doing and producing output into the output file. But if you had any warnings or anything, you could print them into standard error so that people, you would see them, but they wouldn't end up in your output file.
Yeah. To have just basically collect them in a file and not have them kind of. Yeah, I think that's would be pretty nice. I mean, we just have to figure out a way to not overwrite the file each time, but to keep adding.
No, I'm saying the other way around. Like the output should just be the actual output, like the lines you're searching for. That should be in the output file if you like do the right arrow.
Oh yeah.
Errors should just go into the console because you don't want those. You know, if your program was actually partially working and producing some outputs of search lines that had errors or warnings that were not fatal, it could put those in the standard error in your console. And then meanwhile, in the output file is actually the lines that match or whatever your program's doing. So in this case, there's nothing because it never actually managed to match any lines because it had an error, a fatal error, as it were, right?
Yeah, I think we can put it here of like frog.
Yeah, there you go.
OM DST.
Oops. Yeah. No, there
and
you
there
go.
We go. Right.
Yeah,
so I see what you're saying.
Yeah.
Yeah, it's
but you could even put like ePrint line, something like, hey, I'm looking for this in here. And that'll be information to the user, but it wouldn't go in the file. Right.
Yeah. Cool.
You can actually capture errors to the file too, but I think it's greater than $sign or something. I hardly ever use that.
Where in error here, like error?
No, no, in the in your Unix in your terminal, like you can say you can output errors to a file. Anything goes to standard error, you can send that to a different file. I think is it greater than $sign? I hardly ever use this.
Okay.
Anyway, it's just a side point.
Yeah. Well, yeah. Anyways, that was all. Just kind of. We've done some argument parsing. We've handle files. We've worked with refactoring and applied error handling and testing. You know, we've been working out through a book and this neat little small project.
Yeah. And then next week, we're going to come back to this again, actually, a little bit, make some improvements with iterators and closures. So,
okay.
So save your work. I need to go at it again.
Yeah. Let me stop here.